So these are the second part of the notes for section 14.2 on gas laws, and this part of the notes is just on the combined gas law. This is the combined gas law right here where we have pressure, volume, and temperature, and combined as in we're combining Boyle's, Charles, and Gay-Lussac's law all into one. So with the units, kind of the same thing as the other equations. The units have to agree for pressure and volume. They have to be the same on both sides, and temperature has to be in the Kelvin scale. Now let's take a look at a couple practice problems here. The first one says a gas is heated from 263 Kelvin to 298 Kelvin, and the volume is increased from 24 liters to 35 liters by moving a large piston within a cylinder. If the original pressure was 101.3 kPa, what would the final pressure be? So if we highlight the important stuff in the problem, you have your starting temperature right there, so that'll be T1. It changes to that, so that's going to be T2. And these are already in Kelvin, so we're not going to have to make a conversion there. And then we have the volume. That's your starting volume, so that's going to be V1. And there's your, it changes to that, so that's going to be V2. Those are both in liters. And then it says we have an original pressure, so that's going to be P1. And we want to find what would the final pressure be. So that means P2 is going to be what we solve for in the equation. So now if you write out the combined gas law, P1 times V1 over T1 equals P2 times V2 over T2. Now we just take the information from the problem and just plug it in. So P1, we said our initial pressure is right there. So it's 101.3 kPa. V1, our starting volume is 24 liters. And then T1, our starting temperature, 263 Kelvin. All right, now for the final conditions, P2, that's what we're trying to solve for. So we just leave it as P2. V2, it changed to 35 liters. And then T2, we have 298 Kelvin. All right, so that's the equation with all the numbers plugged in. Now we just want to do the algebra and isolate P2 and solve for that. So when we cross multiply, we end up with this. Cross multiply to get everything on one line. So it's 101.3 kPa times 24 liters times 298 Kelvin. P2 times 35 liters times 263 Kelvin. All right, now we just want to divide to isolate P2. So divide both sides by 35 liters and 263 Kelvin. So on this side of the equation, it's going to all cancel out, and you have only P2 left. Now we can just multiply those and divide by those two, and then we'll get our answer. And after doing the math, we get P2 is equal to 78.7, and the units of pressure are kPa. And that's the first practice problem. Second problem says the volume of a gas-filled balloon is 30 liters at 313 Kelvin and 153 kPa pressure. What would the volume be at standard temperature and pressure STP conditions? All right, so we have these initial conditions. So there's our starting volume, there's our starting temperature in Kelvin, and there's our starting pressure. Now we want to find the new volume. So V2 is going to be our unknown, okay? But it says you're changing to standard temperature and pressure. Now, if you remember standard temperature and pressure, that means standard temperature is 273 Kelvin. Standard pressure is going to be 101.3 kPa. So those are your standard conditions. You'll see those in problems every once in a while. So if it says it's changing to STP conditions, these are the conditions that you want to use. 273 Kelvin for the temperature and 101.3 kilopascals for the pressure. All right, now we can plug that into the equation just like we did in the last problem. So we have V1, V1, T1, V2, V2, T2, okay? And now we're solving for V2 again. So now we can just plug everything in that we know. So it's P1 is 153 kPa, V1 is 30 liters, and T1 313 Kelvin. All right, on the 2's now, this is where we put in the STP conditions. So P2 is 101.3 kPa. V2 is what we're solving for. And then T2, 273 Kelvin. Now we just cross multiply and divide again to solve for V2. So it's 153 kPa times 30 liters times 273 Kelvin. That's when we cross multiply here, and that's equal to 101.3 kPa times V2 times 313 Kelvin. Now just divide, just like the last problem, to isolate V2. So you'll divide by 101.3 kPa and 313 Kelvin on each side. Just like that. On the right side of the equation, those cancel, and you have V2 isolated. Now we can just multiply and then divide, and we have V2. And when I do the math, I get V2 is equal to 39.5, and the units for volume are liters, so 39.5 liters. And that's the end of the notes for section 14.2.